Welcome to the Meltzone Podcast, episode 26 from Monday, November 25th, 2019. I'm Tom.
And I'm Stefan. And we both got back from Formnext. Unharmed, still, not sick, I guess. We talk a little bit about this 3D printing show because it is different to a maker fair and just how we experienced it and what we have seen there. And we have actually seen, or Tom has seen, a couple of interesting things about real, like three-dimensional slicing, 3D printing with a robot arm. We also talk a little bit about Bcn3d's new Epsilon 3D printer and kind of a small controversy around their active or not so active heated chamber. All right, on news, Lulzbot is safe. Lulzbot found a buyer and they can continue their business, which is really nice. Also, Autodesk currently gives us generative design in Fusion 360 for free until the end of the year, which was something that was actually reserved for the paid users before. So give it a try.
Yeah. In more news topics, because we're now professional podcasters, we talk about Podimo, the German that wannabe Netflix of podcasts, and on how we should do chapter marks, because you guys keep asking for them, and now we ask you guys if you have an actual solution for how we should implement it. Topic of the week: we're both RC plane dudes, and I've finally got into it. Stefan has been for a while. Printed planes. How to go about them, whether Light Weight PLA is the right approach, or whether using a combination for wings out of hot wired EPP foam can be an alternative. Lots of good stuff there. And then for a few questions, we talk about bulletproof 3D prints that are claimed to be as hard as diamonds, whatever that is. Spoiler alert, it's if it were actual carbon nanotubes that they're basing this design off of, it's not really diamonds. But other questions, actually practical approaches to making stronger parts. Metal 3D printing using hobbyist machines, will we ever see that? Or should we use the Ultrafuse by BASF? And lastly, why do we only review Chinese printers, or why does it seem like we mostly review Chinese printers and none of the Western machines? All right, we've made it back from Formnext, haven't we?
Yeah, we made it back. It was quite a ride. How are you doing? How are you holding up?
You took the train. For you, it was the event was the event.
The event was the event, yeah, actually. But I noticed again that German trains can be kind of horrible, and you can't really rely on them.
Oh, no shit, Sherlock.
Yeah, I thought I would be like ecologically responsible and take the train to Formnext, which should have been just like a 3-hour train ride for me, or 3.5 hours.
You go to Munich, and then Munich to Frankfurt is the ICE, right?
No, it's Ulm, Stuttgart. It's Ulm, and then from Ulm, the ICE over Stuttgart to Frankfurt. But first train already had 10 minutes delay. I had 7 minutes for the change, so I missed my first train. And nice. I ended up like 2 hours later in Frankfurt, which was good because I had lunch at the train station, but worse in the other direction. But it was a free lunch
in the lounge. No.
They
don't have food in the DB lounge. No.
But yeah, I just made it 2 hours later to Formnext, and since I just had like 1.5 days, 2 hours was quite a bit of time missing from my trip.
Yeah.
But you took your electric.
Yeah.
That was quite a ride, wasn't it?
Yeah, I was 2 hours later than I expected too. I don't think I'm much better off there. Yeah, I mean, charging actually does work pretty well, but for some reason that Leaf, I don't know what's up with the range. I had to recharge every 100 kilometers instead of like the rated range of 270. So for me, it was
Seriously?
like 3 charging stops on the way there and on the way back too. And the last stop, because Rapid Gate was instead of 44 kilowatts of charging, 16 kilowatts. So you for a full charge, it takes you like 2 hours. So yeah. But thankfully, the show does have free charging in the parking garage, which you have to reserve a few weeks in advance, which I did. But like if you arrive there at 1 p.m., nobody's there to actually unlock the charger for you. And it's just... Anyways, I got there, got back in one piece. It was fine. It's fine.
Okay. But why did you only get like the 100 kilometers? You weren't speeding on the highway, didn't you?
I was doing 120. I don't know. Either the car is lying to me and how much power it actually uses, because I did the math in how much battery percentage it drains and how much it tells you it's using power-wise. And instead of a 40 kilowatt hour battery, my math tells me it's only got like a 30 kilowatt hour battery. If the numbers the car is telling me are true. I don't know. The dealership that I leased this thing from told me, yeah, you can always do 200 kilometers on charge, like unless you're like really flying down the highway, you can do 200. I've never managed to do 200. I usually run out of juice after 160 or 170 or so.
Okay. And it was, it was cold, but it was not like really,
The battery
really cold.
was scorching hot, or it was anywhere between cold and warm, because every time you charge, it heats up the battery and the battery stays at the temperature. So anyways, that's EVs. People don't care about EVs. I mean, if you look at how many... It's just if it was a Tesla Cybertruck, maybe they'd care about it, but I'm just driving Nissan. Like...
Yeah, that's unfortunate. You should have waited and reserved yourself a new Tesla truck. But
do you like the design?
I wasn't sure if it was a joke.
Yeah, me too. It was like, dude, you can't be serious. Like, they've got the beautiful Roadster coming out. They've got the Model 3, which I've grown to like. Then
it's black and white. Some people hate it. Some people really like it. I don't know. I kind of think it looks ridiculous. But on the other hand, all cars nowadays look like totally the same. So I think it's quite a bold move from Elon Musk to like put a design like that out there, because it's different. It looks spacey. It looks like a Cybertruck. Still don't know if I would purchase one. But it has like this it looks a bit like a DeLorean with its stainless steel outer shell, which is kind of cool.
Steel, yeah. So at first I was like, what the explicit content are you guys doing here? This is how you got to be kidding me. I gotta say it's grown on me a bit. I'm not feeling that urge to vomit when I see pictures of it. I've always liked the front and the back, like the way that crease, that hard edge in the roof. I think that's what's killing it for me. I don't know. It's probably going to be the new normal in 5 years. I think maybe cars are going to start looking like that. But it's.
But I don't know. Yeah. Aerodynamics must be horrible.
That too, yeah.
Must be horrible with such a car.
I mean, it's probably not that. Our brain is probably intuitively telling us, oh, it's got hard edges and it's not swooping water droplet shaped. It can't be aerodynamic. But I'm sure they've got something figured out, because if you look at the range, either they're putting massive batteries in that thing, which at 40K I don't think they are, or it actually is somewhat aerodynamic, because with the ranges you're getting, and it's you've seen how big that thing is. It's a massive car.
Yeah,
it's a truck technically. Sorry, it's not a car. Huh. But have we seen any? Yeah, go ahead.
It's hard for me to imagine how you can make a car out of stainless steel and it's still like ecological, because the weight to strength ratio, especially for sheet metals, is I think not the best with stainless steel, because either you make it horribly thin, which then it probably would have withstood like the smack with the sledgehammer.
It's 3 millimeters thick.
3 millimeters.
It's 3mm outer shell. So typical
tank.
car frame is like, so that the sidewall of a car is typically like 1.2mm, and then thinner parts like doors are 0.8. That's like the standard sheet metal thicknesses. So 3mm is, I mean, not only incredibly rigid, but also, tough. So I don't know. Time will tell.
Time will tell.
I'm still thinking they're going to change the design for the production model. I don't think they're actually going to release it and ship it like that. I don't know.
I thought about if like this like really just polygon shape of the car is easier to manufacture. Probably for the windshields, but otherwise I think it might be even more challenging and more unforgiving.
Yeah, because stamped sheet metal part, like the entire sidewall of a car, you need the tools for that. Yeah, but it's just a it's that, and there's your sidewall, there's your complex swoopy shapes. It's not like somebody's standing there and hammering out the I mean, there's literally no difference. Well, there is some difference, but it's not hard to manufacture a traditional car shape.
Yeah.
Anyways, did we see anything as spacey at Formnext? Just to get the topic back on track here.
Yeah. For me, it was hard because this year it was like 4 really huge halls with 3D printers and 3D printing related stuff. And just seeing everything in 1.5 days is kind of impossible. So yeah, there were the big manufacturers. The good thing was that there were also like more small manufacturers, so more consumer and prosumer stuff. But I didn't see anything like really revolutionary. Many things were just the evolution of things that you have kind of seen already in the last years. I don't know, maybe I missed anything. There wasn't anything really particular that stood out to me that was like, oh man, I would have never thought that something like that is possible. I don't know. How was it for you?
I feel like we've been saying that for years now, that, this show, there's nothing really new and really big. But isn't that good too, that we're at this steady state where, I mean, phones, right? It's the same thing. There's not something that's like super revolutionary coming out in those things. Same with 3D printers, at least FDM, where it's like, hey, this enables new things. No, but it's getting better. It's getting easier to use, more reliable. All those things are now coming together. For me, it was really, like you said, it was hard to take in because it's such a big show. I've not seen Formnext in the years prior. Last time I was there, it was still called Euromold, and at that point, it was a different show, I guess, content-wise, because it was also, traditional injection molding crammed into one show. It was interesting to see that there was, like you said, there was big manufacturers and small ones, and not just big as in a lot of people work there, but also big customers as in companies targeting industrial, and they had 5-axis CNCs and large scale milling and powder welding and all that. But there were also the small filament makers and consumer brands there. I do really like the fact that Formnext has kind of mixed that up. And it's not just purely industrial or purely consumer. I do love shows like Earth and Murph and the other ones that are like that too. But having a small filament manufacturer next to a company making 500,000 euro printers is kind of fun.
Yeah, but the problem was that since nothing was ordered, and everything was just mixed over those 4 halls, it was really hard if you were just browsing through the aisles to find something which, which you were really looking for, because you really had to take the time to take a look at each booth, because by just walking by, you wouldn't know if it was like a 3D printing manufacturer, a software manufacturer, a material manufacturer, or something like that. And I hope that they will change something like that in the future, that you have like a dedicated hall for professional metal 3D printers, one for filament stuff or polymer stuff and things like that, one for software, because just the overview is missing. I don't know if you want to be placed directly next to your competitor, but for me as a visitor, it was just hard. It was really hard. And I think I have just like walked by so many interesting things just because my brain can't really cope with that many things from each booth. So, and I did not have the time to really like say, okay, today I'm only in this hall and I'll really seriously take a look at each of the booths separately.
It almost felt like they were grouping the halls by like the size of the company. There was, I think, one of the 12 dot something. I think the 12.1, the upstairs 12 hall, had all the big companies. I think Siemens was in there. Stratasys was right up front. I think
General Electric,
GE. A lot of big companies were in that hall, and then the other ones were smaller and smaller. The halls were still big, but the companies were smaller that were in there. But maybe having that mixed approach, it's probably not great for the visitor if you're just looking for one specific thing. But if you're a company who's there, you want to, talk to other companies, maybe get some new contacts, figure out, hey, these guys have that problem that we can solve, which you only get, I think, if you have a really mixed floor. And it's not just, oh, here's all the software companies who, all know about the same things.
Yeah, I'm also a little bit torn, but like the other expos, where I've also been in the past shows, they were way more sorted, and it was easier, especially if you did not have that much time to just say, okay, I have one day or I have half of a day and I'll only be in this hall because I know there's the stuff that's interesting for me. Otherwise, it was great. It was really great. Because more consumer and prosumer stuff was there. And also, lots of people from the community showed up. That was really cool, which we didn't have during the last years, because the last years, I think I was the only one there. And I was there also just on business terms. So not like on YouTube terms. So also just on business terms. But this year you were there. Joel 3D Maker Noob. Joe 3D Maker Noob. Joel 3D Printing Nerd. I was there. Vector 3D. How's he called?
Adam?
Adam. Adam was there as well.
Floristique was there.
Yeah, I didn't meet him.
I finally met him in person. I think I fanboyed a bit too hard, but Gino Huiske was there, Voctoprint. Lots of cool people. And I think just the smaller brands shouting out, hey, we're going to be at Formnext is attracting a lot of people too. I think someone like Joel, I think he got flown here by Siemens. Did treat it like a full show that they're going to be filming at, like I do when I travel to the US to film a show and interview people. But one of the highlights from the show, because I actually do want to talk about like two things that we do have in our notes here that I think we need to get to. It's not just talking about meta. So one of the highlights was 3D, who I'll have in a video too that's coming up probably the same time as this podcast. But 3D, that's spelled with like a free-D. What they're doing is they're like a two-man company, startup. They're looking for funding. They're looking for partners. What they're doing is a 5-axis slicing approach, I guess you'd call it. But it's like, it's not slices. It's like carves. I guess you could call it a carver instead of a slicer at that point.
So do they have a homepage?
I think they're like not at the point where they have a homepage yet. They had a really small booth. They only had one thing to show, and it was like a small 6-axis with 5-axis. I mean, it really doesn't matter. I think it was a 6-axis robot, just a robot arm that was printing Tetris pieces. Like, you know, the typical.
Yeah.
There's a name for every Tetris piece, which I don't know because I'm not into Tetris. That S shape. I guess that the thing that Harry Potter has on his forehead, that shape. How else should I explain that shape? That shape that they were printing, and basically where it gets to that first horizontal layer, or that first horizontal section where it takes a 90-degree turn, the printer switches from just printing planar layers to actually printing planar layers on top of planar layers, and then where it goes out sideways, it starts printing, or those planar layers start going into circular layers, basically around that inner crease, that inner edge, and it basically never prints an overhang. Because the layers, the way that the nozzle is oriented, is always perpendicular to what it's printing onto. So it's never halfway over there. So I think they are trying to do a very robust slicing approach or carving approach. I just made up that term, by the way. They didn't call it carving, where you can just give their software your model, and it's figuring out everything by itself. Like how can your arm or your robot platform reach the model actually? How it should ideally slice off certain parts and structure the model to where you do have transitions from one angle to the other, and it's not just sharp, which they can do too, but ideally you want it with smooth transitions in the way that the layers are angled. And it's not the same as the non-planar slicing that we've seen the tech demo of, which is the slick through R conversion, which really just takes your top layer and kind of smooths that over. No, it's using more than XYZ. It's XYZ and 2 or 3 rotational axes that builds the entire model out of non-planar layers. And they've had like the Stanford bunny in there, and it looked really, really good. I've tried to push them into the direction of, hey, like, publish this stuff as open source. Like, people are going to find applications for it, because right now they don't even have a reference mechanical platform. I think in this community, you'd for sure find people who just, oh, by the way, I've got a robot arm. Hey, but I'm trying your slicer and it's working great. You're going to find those sort of people. I've seen so many great things come out of this open source community, and I've suggested to them that, hey, maybe this is one direction that you could go into, but that they're really trying to figure out what their product actually is, whether they want to be like a consulting company that helps companies implement their slicer into their products, whether they just want to license off stuff. They don't know. But that was really cool, and that was the first approach to non-planar or to freeform slicing that was more than just a research project. They are actually going to put this into a product if their plan pans out.
I think I've seen something similar at a research booth of a university where they also had a 6-axis robot arm. And that's really cool, because like the hardware has been there for ages, but we didn't have the software so far to do those crazy things. There are things like that implemented in like very expensive commercial software where you do direct energy deposition, like you said it before, wire arc welding on a robot, or powder laser welding on a robot, but they actually face the same issues. And it's cool that people start making software exactly to take advantage of that technology, because not only enables us to print supportless, but my thing again, you could also optimize the printing algorithm to make your part stronger, because you are not limited in just one layer, because you can do it in all 3 dimensions and lay down the material, which is really, really cool. And that would make continuous fiber reinforced 3D printing finally viable for everything and stuff like that. So that's really
they've
cool.
mentioned that explicitly. They've mentioned like the Markforged approach, where you have fibers not just running in the XY plane, but actually free through the layer. And I think that's a different optimization goal, because right now what I've seen is it's just okay, we need to make this thing printable. But if they can still print with supports, they can still add supports, obviously. If you optimize for like the Stanford bunny ear, you don't want that ear to have the layers oriented in the perfect way to print it for strength. Because then you have just the really tiny layers that they're going to crack. You actually want to print that ear in one long swoop. If you optimize for that, then you automatically get stronger prints. And that, I think that should be possible. If you have a solid software basis, that should be possible too.
Well, in the end, you kind of need to section your part or have different areas where you want different printing orientations. And if your optimization goal is printability, that's fine. But you could also have other optimization goals to make use of the technology in another way. And that's really cool. That is something I would call more revolutionary than other things I have seen on the exposition.
Yeah, for sure. And their big thing was you have to keep in mind the geometry of whatever your tool head is, whatever your arm or your motion platform can do. That is your number one constraint that makes it so hard to port this thing from one person doing it on a 5-axis mill to another person doing it with a 6-axis robot arm.
Yeah.
So that's that.
Really cool.
And the other thing that I've noted down here is the Bcn3d Epsilon.
Yep.
Controversies. The internet loves them. Does it have an active heated chamber? Have you taken a look at the Epsilon?
Yes, I was at their booth and I talked to the CTO. It was really interesting. It's a really, really nice machine, as 3D Maker Noob called it, huggable. It's basically their like small IDEX 3D printer in a nice enclosure, a little bit bigger. And like designed for industrial 3D printing.
It ain't small, man.
No, it ain't not small anymore.
Yeah. Well,
I don't know. Can you tell me what the print volume is? But it's something like 400 by
it's
400
420 by 300 by 400 millimeters.
Yeah. So it's
and I think
size.
that print envelope is reachable by both tool heads, because they park off to the side, which is not something that you can do with the Ultimakers.
Yep. And it's definitely competing with the new Ultimaker Pro Pack. Was it called Pro Pack? Pro?
Yeah, no, I don't know. I mean, it's competing with the base Ultimaker S5. It's a bit bigger. It's a bit more expensive.
Yeah.
But it doesn't have, like, it's not a 5-filament pre-selection. It's just 2 filaments that you load into the printer. It's got a filament sensor though, so it's something. What else is the filament? The Ultimaker Pro Pack Pro.
Well, you have the hood that has the filter, and probably also like environmental control that you can print with like a little bit hotter room temperature in there, which is good for demanding materials like ABS, polycarbonate, nylon, which brings us to the controversy point.
Yeah. Is it? I mean, it's a heated chamber, right? Obviously, it's a chamber and it gets warmer there, so it's heated. But apparently, there was a bit of a discussion on Twitter the other day whether it was a active heated chamber, a heated chamber, or a passive heated chamber, because I think Bcn3d weren't really clear that it was only it's an actively controlled heated chamber, to be super accurate, but it's a passively heated one. It doesn't have like a hairdryer heater in there. It's just the heated bed heating up the air in that chamber, and they've got a small fan. If it gets too hot, if it goes beyond that set temperature that I think you probably can set, that fan kicks on, it blows some air out the back, and it cools off that chamber. Though that only cools down like 2 or 3 degrees, so it doesn't really do much. But apparently, because of the way that the temperatures of the heated bed are set for your material, the heated chamber itself heats up to the more or less ideal temperature anyways for that material. So with an ABS, you get like 60 degrees ambient temperature in that chamber. With PLA, obviously that temperature is going to be lower, which is good because you don't really need much extra temperature for printing PLA. In fact, you might sometimes want less temperature in there.
Yeah.
You can always open the door. So,
which is kind of spoiling the nice thing about an enclosure. And that's also probably an issue with the Ultimaker. I don't know. They probably are able to handle it quite well with just like leaving the big fan on in there, that everything has kind of ambient temperature around there, but PLA might be a little bit harder to print. So I just checked before we started the show, and now they are saying on their website that it is a passively heated chamber.
I did check too. Apparently in some other spot it wasn't, that passive was missing, but okay.
Yeah.
Whatever. I mean, the patent on Stratasys' heated chambers run out anyways, so
I was actually checking that as well, and I read something that it was like prolonged until 2021 or something like that.
Can you do that?
I'm not 100% sure, but I've just read something at some point, and I'm not 100% sure if the Stratasys patent are actually for all of the heated chambers, or if it's just, so the Stratasys machines, they have their motors and like most of the print head outside of the heated chamber. They use something like a accordion, like a curtain thing on the top that isolates motors and the extruder from the hot temperatures from the chamber. And I found patents for those, but yeah,
that's my understanding too. It's not for the entirety of just having an enclosed chamber. It's for that specific thing that you get your temperature sensitive components outside that hot chamber,
which is pretty good for everyone, because then maybe heated chambers become more and more common, which enables us in the
when
end.
it runs out.
When it runs out, yeah.
I'm glad that you're cheering for patents running out too. Yeah, I've seen some creative workarounds of that heated chamber, or that not using that sort of curtained accordion style rubber. I don't know if it's rubber.
Have you seen how are those guys called? They are also like a smaller company from Aachen.
No, I've seen it. I've seen it at a mid to bigger size company, not from Germany.
Okay, and they were actually using like a big plate around the hot end, which was heated, so it was always just like radiating heat on the print at the area where it was printing.
So an anti-part cooling fan,
something like that. Yeah.
All right. Okay, but yeah, that's the Bcn3d Epsilon. It's 8,000 something, depending on, of course, where you buy it. Between 8,000 and 9,000 euros, including tax. So a bit more expensive than the Ultimaker, I think, but reasonable and bigger, and it's mostly compatible with the Sigmas. So
yeah,
that's that. And before we move on to the next topic, I do want to give a shout out to Gina for shepherding us through Frankfurt on that. Was it Wednesday night? I think it was. Yeah,
it was Wednesday night. Yeah.
Yeah, let the memes commence. Basically, Gina took us out for dinner, or guided us to dinner, because she's from the Frankfurt area. And yeah, it was a good time. Thank you, Gina. Gina's probably not listening, but if you guys meet her, give her a high five or a fist bump or whatever you're into.
Something like that. Yeah, I really enjoyed it. I hope you enjoyed it as well. And I'm looking forward to be there next year, and maybe a day more or something like that. Or I don't know.
Yeah, for me, it was only 23 hours basically that was in Frankfurt. I thought like, you just drive there and you drive back and don't make it a big deal. Maybe I should make it a bit bigger deal next time, but we will see how 2020 goes.
Yes.
And it's that time of the year where you're like, oh, the year's ending and it's 2020 now. The decade's over, actually.
Don't start with that. And the end of the year usually gets really stressful. That's what I'm really not looking forward to, because things need to be finished. Well, on the other hand, ad revenue is usually better at the end of the year, so that's good for us.
I guess, yeah. If you just want to show for random products, which is a question that we will get to at the end of the video, actually. So
yeah.
I mean, you've already seen. So, by the way, quick behind the scenes here. The way we record these podcasts is we do the content first. We've got our script listed out. We've got our plan of what we want to talk about. But because we don't know what we'll actually get to talking about, whether we're going to, ramble about, Formnext for half an hour, that can happen, which is like this much of our script. We do that intro where we talk about what we're going to be talking about at the very end once we're done recording. So we've not actually done the intro at this point, but you will already have listened to it. So
yes.
you guys will know what we will be talking about, but we don't know that yet. There's the, what's it called? The fourth wall? Third wall? Fourth wall? Something.
All right. Yeah, let's continue with news. So, you want to start?
Yeah, Lulzbot. I think we can do these relatively quickly. Yep. Maybe. Lulzbot is safe. They found an investor, or somebody who's buying their company. So Lulzbot, last time we talked, I think, were still struggling because they were running out of cash. They were laying off people left and right, and they've cut down their workforce by a very significant margin. So at that time, news wasn't yet that Lulzbot was done for. It was only like, we're gonna find a contingency plan, and they did. They found. Let me actually open up the article again in my tiny Chrome tabs. Fame3D, who I've never heard of, are buying up Lulzbot, and apparently they're committing to supporting the existing printers, and they will be making the TAS lineup and mini lineup of Lulzbot's machines under the Lulzbot brand, with a part of the original Lulzbot staff. So yeah, ALF Objects is still kicking and around.
The name Fargo Engineering, or how are they called?
Fargo Additive Manufacturing Equipment. Fame3D.
Fargo tells me something, but I can't remember where I heard it before.
It was a movie.
Yeah, probably.
Which I don't think I've ever seen. Guys, let me know. Should I watch that thing? I've got it maybe on Netflix.
Yeah.
Sure.
Yeah. Netflix. Cool. Yeah. Happy to hear that.
Lulzbot is safe. Your mic just did something really weird. At least it sounded kind of weird to me.
Okay.
Might have just been Google Meet, but whatever. Let's move on with the news.
Generative design.
It's your topic.
Yeah. Generative design in Fusion 360 is currently free to use until the end of the year if you don't have a paid subscription, which probably most of you have, which is really cool. So generative design before was only available for like the expensive paid version, and you also had to use cloud credits and things like that. But Autodesk made it free for the free license and the hobby and entrepreneur license, startup license.
Is this apparently it's the same license now?
Yeah, something. I've
still
that.
Not my head around that, but so it's free. It is. So it wasn't even included in those free or lower tier versions before at all. No. And now it's not only is it included, but you're also not using cloud credits for it.
No.
Am I getting that right?
Yes. It's totally free until the end of the year, 1st of January. It will somehow go back to only the paid version. I don't know if this is just a promotion or if they want to see more applications of that and stuff like that. But I'm really looking forward to, because I really want to play around with generative design and see what applications might be interesting and what the real difference between topology optimization, or like the topology optimization tool in Fusion 360, and generative design is, because it always looked kind of nice, but there wasn't really that much information around because it wasn't free and not many were using it, supposedly. Yeah. So yeah, if you also use Fusion 360, give it a try. Don't use all of the server capacity because otherwise I'm not able to use it anymore. But yeah, really, really give it a try. And I will also link a video tutorial down in the description, which I just found when I was looking for generative design in Fusion 360.
Nice. So yeah, it's probably, the results are probably going to be somewhat similar to topology optimization because, the entire organic thing is also happening, but it's a different approach. It's not giving you a mesh, it's giving you actual geometry, and we've quickly discussed this at Formnext, but the way I've understood it is that generative design actually generates your geometry. You give it like constraints. I've got a bolt hole here and I've got a load there, and it creates some sort of geometry between that. Whereas topology optimization, you give it like you give generative design an area to work in, a volume to work in. Whereas topology optimization, you give it that volume, you create a block first, and then it cuts away everything that it doesn't need. But yeah, if you try it out, leave a comment. Let us know how it goes.
Yeah. Maybe you can do another one of those spacey shelf brackets. I definitely need to make some more because I currently have the problem that I have so many rolls of filament around here and I don't know where to put them. Yeah, and they're just blocking my whole like shelf next to me.
I mean, for those, I would recommend just getting a Steckregal. Because those are like rated for 60 kilograms per shelf or something. I wouldn't trust those on 3D printed races.
Yeah, come on. If you take a look at Joel's office, he has all his filaments on his like really flimsy 3D printed shelf things, and I gotta ask him, but I don't know if they ever broke. Well, anyways,
okay. Well, that is generative design.
Yeah,
very interesting stuff. Two quick things about meta podcasting topics. The first one is Podimo. So, they are a German company, pushed up to the top of the podcasting game by 6 million euros of venture capital. They want to be the next Netflix of podcasts. Now, what they're basically doing is they're a podcatcher, like the app that I use. I use Pocket Cast to listen to all my podcasts. So basically, Podimo are accumulating all the podcasts from the internet. They're putting it into their platform, into their, I guess it's behind a sign-in wall at least, into their app and into their web platform, and saying, hey, this is, we're offering you all these podcasts from, a single source. We're the new, go-to source for podcasts. Now, because we're not... I personally don't care about this podcast being on there. And yes, they have scooped up our podcast as well and put it onto their platform. I personally don't have a problem with my podcast, or our podcast, technically, being on there. I don't know, Stefan, we've briefly talked about what Podimo is. I don't think you have a problem of having the Meltzone listed on there as well. Do you?
No, I don't. Well,
no. Okay.
Well, we discussed about that. It's just like more exposure, more ways to listen to it.
Yeah. So here's the problem that's coming up. And this is out of solidarity. That doesn't sound right. It's solidarität. Doesn't sound right in English. But other podcasters are having a problem with the way that Podimo are going on about this. So what Podimo are doing is they're basically going to the iTunes library and they're going like, hey, let's ingest all these podcasts. They're going over to Spotify and they're scooping up every single RSS feed of a podcast they can find, putting on the app, and basically using free podcasts like ours to pad their library so they can sell their premium subscriptions. And what they're saying the premium subscription does is you can support the podcasters that you love, which we're not seeing a single penny off of that. Now, there are two things that they're trying to do here. First of all, Podimo are producing 10 exclusive podcasts themselves that only will end up on their platform. And basically, your money goes towards those podcasts first and foremost. Secondly, is that they're offering you two basically contracts with them. And the first one is you can publish your podcasts everywhere like we do. We just want to be available everywhere. And they will give you a whopping 20% of what you're paying Podimo for their service of you. They're not even hosting it for you. So the traffic is still on our server. They're basically just copying the description and then showing it in their app. That's all they're doing. And they take an 80% cut for their service. You can also do an exclusive agreement with them where you don't get to play or show your podcast anywhere else but Podimo, and you're getting a 60% cut, which you would have to be crazy to take that deal, because really, you, as a podcast, that's not how podcasting works. And yeah, if you don't take a deal with them, like you're getting nothing at all. The thing is, the way that Podimo are approaching this is upsetting a lot of people, because they're saying, hey, we're just taking all these podcasts, we're ingesting them. And if you have a problem with us ingesting your podcast, just write us an email and we'll take it down. And that's like, hey, we can steal all your content. That's what it's being perceived as. We can steal whoever's content we want, and if you got a problem with it, just we'll take it down. The problem is, of course, they don't respond to emails. There's nobody there to reach, and they don't actually take down smaller podcasts. If it's a big podcast, maybe, but they're just shooting themselves in the knee, in the leg, in the ankle, in whatever lower body parts that are below your waist, by being so self-obsessed about their platform. And if you're listening to this podcast on Podimo right now, again, I don't have a problem with that. Stefan doesn't have a problem with that, but you may be better off actually listening on iTunes or Pocket Casts, or adding the RSS feed to whatever app you want, instead of getting pushed into the Podimo premium subscription model, because again, you're not really supporting any of the podcasts you're probably listening to.
Yeah,
that's just that. I mean,
we rather support your creators over Patreon or something like that.
Oh yeah, totally. Yeah. Patreon, PayPal. Do we have a donation bank account? I gotta look into whether we can actually just do a bank account, a secondary account or something, where people can chuck us a coffee or a beer every now and then.
Yeah.
With no PayPal fees and stuff.
Yeah.
With no 80% cut to Podimo. Like, crazy.
Even Patreon is not taking that much. Even YouTube is not taking that much.
Yeah. I've actually asked YouTube in the workshop how much they're taking off of YouTube memberships, and it's 30% is what they're taking. That's the official number. So yeah,
that's the same like with super chats and stuff like that.
I believe so. Yeah. So if you want to support your creators directly, PayPal, bank account, direct donations, that always ends up with more money in their pocket, less money going to the platforms. Yeah. Whatever you want to do. But yes, I would not recommend using Podimo, just because some people that I respect have a problem with the way that Podimo are handling things. I will link a German article, or Stefan actually will link a German article underneath this podcast, where you can read the entire rant in its whole glory.
Yeah. Next topic, chapter marks. So people are approaching us always in the comments under the, at least under the YouTube podcast, that they want to have chapter marks so that they can skip to the topics that are interesting for them. I'm not 100% sure what I think about that, because for me, podcasting is a format where you start listening in the beginning and stop listening in the end, and you don't just jump around for the things that are interesting for you. But if people are... Sorry, go ahead.
Yeah, I mean, same for me. I listen to an entire podcast episode, and if it's... I don't jump through, so...
Yeah. And also, listening to a podcast shouldn't be the only thing you're doing. So if you're listening to a podcast, clean the house, I don't know, drive to
laundry,
work or something like that. Anyways, so our problem still is, even though we could put it under the podcast itself on YouTube, we are thinking about like getting a software or tool where we can also provide chapter marks in the podcast app itself. But that turns out to be quite difficult. And maybe you can say a couple of words there.
Yeah. So the like you said, like what we could do is just put some timestamps in the YouTube description, but people who listen or watch on YouTube, they're probably not going to find that in the description because, show more and all that. But it's also not helping anyone who's just listening to the audio version. There are a few ways to do it, like in the actual MP3 file, apparently. But like you said, we've not found a tool that does that very efficiently. And just providing it in one space where, we still have to do all the work to actually mark it and put that into a format that is readable to people and to tools, and just having to show up in one place where we get maybe 20% of listens doesn't make a whole lot of sense. So if you guys have a recommendation for either a podcasting recording tool that lets us record remotely, because we're not in the same room, as you may have guessed by now, lets us record remotely, does handles audio stuff possibly, because right now we're just recording into Adobe Audition, does chapter marks in an MP3 export. If you know a tool that does that, that would be awesome. I do have one marked down, but I don't want to bias you guys before we start here. If you know a tool for that would be great. Or if you know a tool that works on Windows, because we're both Windows guys, that can mark an MP3 file and where podcasting or podcatchers will actually pick up those chapter marks and show it to you as a skippable mark or chapter, then please let us know, and we will take a look at those.
Definitely.
Yeah.
All right. Let's continue to the topic of the week.
Yes.
Show it to us.
Oh. Yeah. Oh, I took out a nose piece. This is what I've been spending my. I'm probably gonna have to hold it like this so that when we split screen, we can actually see the entire thing. This has. I mean, I've always been an RC guy, and I feel like a lot of people who are into 3D printing kind of share that, where we're both, printing stuff, but we've had experiences with RC cars or planes or whatever. So I've always been a RC car, buggy, monster truck, all that guy. And I finally decided to take up flying, and I've been flying wings, and it's been a whole lot of fun. But the reason why I'm getting into it, obviously, because I've seen, 3D printed planes.
Yeah.
And you've actually done one. I didn't know that before.
So I've been into RC flying for 20 years or more.
This thing's still wet. It's super foggy today.
Yeah, horrible weather outside. So yeah, I've been into RC flying for 20 years. I started when I was really young, then just didn't continue because I was too scared of you ruining my plane. And then continued flying, 12 years ago, 10 years ago. When the first foam airplanes came on the market that weren't styrofoam, so they weren't exploding when you just hit the ground lightly.
Yeah.
So EPP, EPO, and things like that.
Same stuff. So it's basically foamed polypropylene, which we love as a 3D printing material.
Yeah,
and
which is really impact resistant. It doesn't scatter like expanded polystyrol. Anyways, so that made just.
Crap! I've already cut this one, so of course it cracks.
That just made getting into flying so easy, because you could crash your plane, and it wasn't really bad in the end, because worst thing that could happen is glue a couple of parts back together and you're good to go again, and that is working quite well with super glue. Yeah. And then, like, it was a long time ago, like 3-4 years ago, I saw a video, I think on Flight Test, where they showed a 3D printed P38 Lightning, which was just gorgeous to take a look at. And at some point, I started, I printed my own plane. I did, I think, a 3-part video series on that. 3 parts being that I tested print settings to get the hull as strong as possible, and then I printed that Messerschmitt ME 109, something like that, which flies really well. It's crazy. So the plans or the STLs can actually be purchased at 3D Lab Print, that has a ton of different airplanes on their platform to sell. The files are awesome. There is really some art in those designs, how they arrange the parts in there that you get this really lightweight structure and that is printing properly in the end. You glue it together, you fly it. It's a bit heavy, to be honest. So it flies a little bit faster than a foam airplane. But
a 3D printed plane wouldn't be something I'd recommend, or one would recommend for beginners, because you land a bit too hard, and it's a bit harder to repair than foam, right?
Yeah. You could argue that if your plane breaks, just print another one. Still, it's I think the Messerschmitt has something like 600 grams of material in there, or 800 or something like that. So it takes you quite a while to print that. And
if you need to replace a part, you have to, somehow extract the broken one, and you have to glue it back in and make it perfect. Yeah. So yeah,
it's really cool. I have been flying it like once. I crashed it like 3 times. Now it's just sitting on my wall and looking really nice.
Actually, it's behind you, isn't it? Right?
It is behind me.
Yeah.
I don't know. I think you can see it on the camera, but usually on my videos,
I can see it in the video feed.
Yeah, you can see it. It's cool. It's really, really cool. And well, since you now started getting into RC planes again, I kind of have the temptation to also get my planes out again and just fly around a little bit more, because I have FPV gear. And if you guys don't know what that is, it's like a radio, like a wireless camera in there.
Basically, you put a small camera in the front and the transmitter, and you either put on goggles. Go ahead.
Yeah. And you have goggles, and you feel like you are flying the plane yourself, which is really, really cool. A really nice experience. It is way better than if you have, for example, a DJI drone and just take a look at the screen on your phone or something like that, because you really feel immersed. And since this is all using analog technology, there is basically no latency in the signal, so you can do some really crazy stuff with the airplanes and also with quadcopters and stuff like that.
Yeah.
But you started now with the foam planes. Do you plan?
Yes.
Do you plan also printing one or even designing one yourself? A 3D printable one?
Yes. I mean, the entire reason why I bought. So I've got, this is the S800 Sky Shadow, really popular wing. The other one I got was the Hobby King Bonsai 2, which is a small one, 600 millimeter, way lighter, about 250 grams. This one is like 450. The only reason why I bought these was because I wanted a reference design that I could base my design off of, because I honestly have no idea about designing planes. I've watched a ton of flight tests, as you probably have. I've binged Tom Stanton and RC Test Flight and all those guys, just learning about what makes a piece of foam or geometry fly, and just why, for example, these wings are shaped. So this is the direction it flies. Sorry, audio listeners, but if you're basically looking at this, it has the wing swooping back. Why does it have that? Well, because it stabilizes the wing in that direction. Why do sailplanes have dihedral, where the wings actually point upwards if you look at it from the center? Yeah, because it stabilizes it in that direction. Stuff like that, where you don't think about it when you just see, oh yeah, that's how a plane looks. Yeah, sure, but you don't think about why it looks that way. So yes, I've thought about different ways of approaching the 3D printed plane. We've seen the full PLA, basically spar and then the shell over it construction, as you'd see with balsa planes, where you have just thin balsa spars and then have a film over it. That's what your plane is built like?
Yep.
I thought about doing a similar thing with the Colorfab Light Weight PLA.
Yes.
Mr. Horn seems to be quite a fan of that. So the lightweight PLA is a PLA that foams while you print it. So you have a roll. Yeah, they've offered me a roll too. I need to get back to them. It's extruded. Apparently, the filament itself is extruded in production at a lower temperature, and then when you first shove it through your nozzle at a higher-ish temperature, it creates air pockets because it basically becomes a sponge. So that gives you, I guess, still a decent extrusion width and rigidity, mostly, I'd hope, while being much, much lighter. I think it's only like 60% of the weight when working perfectly or something. Do you know the exact number?
So you can adjust the density depending on the printing temperature. If you print at lower temperatures, you still get like 80, 90, even 100% of density from the material. Yep. But the higher the temperature, the more foaming you'll get. So there's a foaming agent in the filament itself. I think it's kind of similar to what Polymaker, for example, does in their polywood filament, which is not wood.
Right. Yes. I just looked it up, actually. They're claiming increasing its volume by nearly 3 times.
Which would be like 33% density in the end.
That would be amazing. Okay, yeah. I gotta try this stuff. You can decrease material flow by 60% when you're printing at ideal temperatures. So that would be amazing, obviously, because as you mentioned with your plane, 3D printed wings or planes are kind of heavy. So that would be an option. And I've also considered, basically, let me pick this thing up again. Basically just having the center canopy, fuselage, whatever you call it, with a wing, because I feel like I want to stick with just flying wings. I think they're kind of cool, and they're less complex than having a fuselage and then a tail and all that,
but way more unstable.
Yeah, well, I put flight controllers in mine, like so, that doesn't always help. It sometimes crashes your plane too, but just printing the center section and then hot wiring the wings. We're doing something with the wings that is a more lightweight process, because really the complex part is that center canopy where you put all your gear and all your stuff, receiver, flight controller, battery, FPV gear, that all goes in here, and then the wings are relatively simple shapes, really. Like I mentioned, there are carbon spars and reinforcements, but it's not something that you couldn't do with a hot wire, for example.
No. And it would be probably like sufficiently stable if you would do the wings in foam and just reinforce them with carbon spars, or even just packing tape on top.
Yeah, though to be honest, I've not found a tape that really sticks to EPA. EPA. That's the U.S. agency, to EPP. Because polypropylene is kind of, it feels kind of oily, and I've not found a packing tape, at least with the bonsai, which is a hot wire type one. This is molded. Gaff tape is actually the only tape that I found that sticks to it well. This is brand name gaff tape. I don't know the exact brand, but this sticks. Packing tape has always come off.
No.
So, yeah, but something like this where there's just a carbon spar in it, or actually a carbon tube running through the entire first third of the wing, would definitely help. And foam works for these wings perfectly.
Definitely.
So, yeah, there's lots of room to experiment. And it's something that I'm really excited about right now, because for me, it's a learning experience. I think that's yeah.
So, well, maybe coming back to the lightweight PLA, because I also think this is a really interesting material and it's not used that much so far. So I also have like a roll on my shelf for couple of months, and I wanted to do a video on that for quite a while. And actually, the guys from Eclipson airplanes that kind of do the same thing as 3D Lab Print does. So they're also designing 3D printable planes. They told me about the material and said, okay, they're currently working with that material for their airplanes because they see the benefit in lighter structure. And they have already printed one of their planes in the Light Weight PLA and told me that they had really good success with it. It's less stiff, obviously, if the density is lower.
Yeah.
But you can still use like the carbon spars in there, so you can still get a really like lightweight structure and just reinforce it with the spars to make it stiff. So yeah, I'm really planning to do a couple of tests to see if like the strength or the stiffness is linearly dependent on the amount of foaming or the density that you have. Because as I said, there are really interesting applications where this could be useful. And what I, for example, also see, if you have a dual nozzle 3D printer, you could load this material in one nozzle and load like normal PLA in the other nozzle and only do like the outer hull of a wing or of the airplane itself with a lightweight PLA. And at the sections where you really need the strength, there use standard PLA, and they should be like combining pretty well if they're both PLA.
They should stick to each other for sure.
Yeah, they should stick to each other.
But wouldn't you do it the other way around if you want rigidity? As in stiffness, you do the standard PLA on the outside and the foam on the inside, like you said with packing tape on foam?
Yeah, maybe, but I think with a standard nozzle, a 0.4 millimeter hull is just actually way too stiff or way too thick.
For sure.
You need a thinner one. So either you use a thinner nozzle or you use this lightweight PLA, which might also be beneficial. I don't know what's better in the end. I also thought about using like a single nozzle approach, because depending on the temperature in your hot end, you can adjust the density of the material just on the fly. So what I made in the past is I made like multi-tone 3D prints with wood filament, where I took a multicolor 3D printed part, and instead of switching nozzles or materials, I just changed the temperature of my hot end. And some brands of wood filament, they severely change color depending on the printing temperature.
Yeah, because you're caramelizing the wood basically, right?
Exactly. But the thing is, the thermal mass of the hot end is so high that you need quite a big purge block in between in order to get the temperatures, either lower or higher, which is kind of a downside of that approach. But still, it works in the end. So you could do something similar like that with lightweight PLA and have a part that doesn't only have like non-consistent density over the part due to the infill structure, but you could also like tone the material density in an intelligent way in order that you use the material the most efficient way. And that is pretty cool.
Yeah. I mean, if you think about what foaming actually is, it's the same approach as doing infill. It's just on a much smaller scale.
Exactly.
Right? You're creating that sponge texture instead of having it, in a 10 millimeter grid. You're doing it on a 10 micron grid. Yeah. So yeah, lots of potential there. And I think for stuff where weight matters, and you just need for wing, really, you just need the geometry of the airfoil. That's really what matters. And if it's heavier, it's just more weight you have to account for it down the road. It's kind of this classic rocket problem, where the heavier you make it, the heavier you have to make it because it's heavy.
Yeah.
So yeah, could be a lot of fun. I'm just enjoying flying right now, and glad I got into it. And 3D printing inspired me to do that.
That is really nice because, I have talked to many other like RC guys, and the way they actually came into 3D printing was, okay, I finally have a method to get my designs into parts for my RC planes or cars really fast, because I don't need to use conventional manufacturing. I just do the CAD design, print it out, and it's ready to go. Even though they might learn at some point that strength might be an issue, especially compared to like aluminum or injection molded parts. But if you design it properly, 3D prints can really hold up quite a bit. And taking a look at the 3D printable airplane I have behind me, it is strong enough to do quite a lot of things. And I crashed it several times. And it didn't look too bad. I didn't really have to print any spare parts for it.
All right, bit of packing tape, fix it right up.
Yeah.
I just think that there's, as we've seen with someone like Tom Stanton, obviously he's the poster child for this. You've met him at XYZ Summit.
Yes.
I think there's just a massive overlap of people who enjoy 3D printing and people who enjoy RC stuff, be it planes or cars, trucks, all that. It's a very similar experience, I think, tinkering wise and actually using the thing where the tinkering itself is as much a part of the hobby as the using the thing.
Yeah.
So yeah. And there's lots to learn, obviously, which can be confusing, but it's also very rewarding once you figure out, oh yeah, that's how that works. And yeah, the entire, like this is playing off of the entire drone and quadcopter game with flight control and all that. I think that's really made parts very easily and cheaply available. And it's also pushed the software a lot. Like I can program my speed controller through USB if I just plug it into my flight controller, which will make no sense at all if you've never used these parts, the words that I'm saying, but everything just works beautifully together. It's a bit tricky to configure, but it feels really solid. And it's all open source too, so that's amazing, obviously.
Yeah, cool. Yeah, maybe we find the time at some point to go flying together and do something like Warbird, whose plane will crash at first, something.
Oh, I gotta get. I don't want to wreck this one. Maybe I should do like a disposable one first.
3D printable.
Yeah, easy replacement parts.
Yeah. Cool. All right. Let's head over to questions, shall we?
Yes, let's do that. Which one should we start with?
Yeah, I think with the first one. So, who was asking that? So, there actually was an article on a couple of sites, Gizmodo, for example, a couple of days ago, that researchers 3D printed plastic cubes with complex patterns that made them bulletproof. And
Kyle Taylor on Twitter pointed it out to us.
Oh, yeah. I have seen that. Unfortunately, the paper itself is not accessible if you're not paying for it, but I don't know. Have you read it? I have not, no. Okay. I've just read the article on a couple of pages where they featured that. But basically what they said, they printed like carbon nanotube structure, and they shot like a solid block with a high velocity projectile and the 3D printed plastic cube, and the 3D printed plastic cube with the special structure held up way better. For me, it's a bit, I don't know what I think about that. As I said, I didn't read the paper itself, but for me, it just looked like, okay, on the one hand, you have a big piece of plastic, and if you shoot it, it will scatter because everything is connected. And then you have the block, which has voids on the inside and has like layer lines and stuff like that. And if you shoot that one, cracks and also the impact will not propagate as far through the material that everything is shattering in the end. What I want to say with that is I'm not 100% sure if their crazy structure made the part bulletproof or just the process of printing it, and many other structures would have had the same effect.
Yeah, obviously it's easy to go off of those headlines. Resulting in plastic objects that are almost as hard and durable as diamond. Yeah, I don't know how a material can be harder than, or a metamaterial, a structure made of, can be harder than it ain't. Sorry, it doesn't work that way. I guess if it was made out of carbon nanotubes, it would be as hard and as durable as diamonds, maybe, but not if it's printed from plastic at a larger scale.
Yeah.
Now, yeah, you're saying, hey, if this was another infill structure, it would have dispersed the energy just as well. And yeah, I see that. I see it. It's kind of like the what's the new infill structure?
Gyroids.
Gyroid, right. Which is supposed to be like the absolutely strongest, most rigid. I don't remember what they're claiming exactly. Structure you can create as a metamaterial. Here, I think it's just different. It's a material that is compliant, because that's what you need to absorb energy from whatever projectile you chuck at it. It doesn't need to be. It shouldn't be stiff.
Mm-hmm.
I mean, I guess it's cool, but it's. I'm not a fan of overhyping stuff like, oh, this is, we can 3D print diamonds out of or material that is as good as diamonds out of plastic. No.
Yeah, I get that. If you guys are interested, we'll leave links to the article and maybe the paper down in the show notes.
Yeah, it's just a really squishy infill structure, basically.
Yeah,
they've created.
All right. Next question.
Next question. Andrew Hayes. Do you think metal 3D printing will evolve into the hobbyist market? And if so, how long do you think it will take? And I guess the next one from Mac One Board. Mac One Board. Yeah, that makes sense. Fellas, have you tried UltraFuse 316 BASF stainless part filament service? Is there a way of sintering at home? So, Stefan, you've talked to the BASF guys at Formnext.
Yes, I did.
The folks from MatterHackers are also offering that service of post-processing the 316 prints. But can you sum up what that looks like right now, what that process looks like?
So, currently you buy a spool of filament, which, don't quote me on that, is something like €100 per kilogram, something in that range. I think even a bit more expensive. You print basically the part, the so-called green part, which should be a little bit bigger, around 18-20%, because it will later shrink during the sintering process. Print it out, ship it to one of BASF's like debindering and sintering suppliers, which in Germany is handled by something like a subsidiary of iGo3D. In the US, I think MatterHackers somehow handle that. Yeah. They will charge you around, I think, $60 per kilogram.
So that's not included in the spool price?
That is not included in the spool price. Okay. That's an additional amount of money you have to pay to get the parts debindered and sintered. Debindering means removing like the leftover polymer that is still holding like the cake of metal together.
Yeah, because the filament itself, to be printable, is not just metal powder compressed into filament. It's
metal with
the
a
powder
binder
suspended in some plastic that burns out, like a PP or a PLA or something that it can just burn away.
It's actually not burned out. It's catalytically debindered, which means that the part is put in an oven at a temperature of, I don't know, I think between 150 and 250 degrees Celsius with ammonia or something like that, and that is then slowly chewing away the chains of polymer.
Converted.
So
Okay,
it's not burned
interesting.
out. It's not burned
It's
out.
more
So
like washed out, I guess.
it's kind of washed out. Desktop metal, they're using a washing process where you kind of just wash the binder out with a solvent. The BASF Ultrafuse works with catalytic debindering, where you need a special oven for it with a special atmosphere. After that, you have your brown part, which is the metal powder without the polymer, or just really small remainders of the polymer left.
Probably fragile as all hell.
Yeah, it is fragile. And then you take this part and put it into the sintering oven. And sintering is happening, I think, at 80% of the melting temperature of the material. So those temperatures are way higher than during debindering. And during that process, really the leftover metal balls or spheres or something like that, they sinter together. And sintering together also means that the volume is reduced and the density is increased, which means that the part will shrink in the end, and you will get a part that is 96 to 98% dense in the end after the sintering process. It is not fully dense. It still has voids on the inside, but it is almost as dense as like normal material. But the problem is the parts will shrink, the parts will warp. You need to account for that. So you do not only need to change the sizing of the part. It might even be necessary, depending on the shape of the part, that you really like deform it beforehand. And this is kind of the interesting and also complicated process. I think BASF is tackling that by simulation they offer for the customers. So you can basically put your STL in there. They do a sintering simulation, and you get a pre-deformed STL that you then print out. And this way, the chance is bigger that the final part will have the shape as it should be.
Yeah. Do you know anything about what the final strength of your part is going to be? Because if you have just a solid rolled, cast, whatever chunk of steel, like that is very nearly 100% dense. But as soon as you include those voids, I'd imagine, because it used to be balls that basically you heat them up so much that they kind of start sticking together like a water droplet soaks onto it.
Exactly.
Yeah, kind of like that. They stick together, but there's still all these notches and voids and stuff on the inside. So
you can take
that would have a significant impact on strength.
You can take a look at the material values that are in the BASF data sheets, or just the MIM data sheets, so metal injection molding, where kind of the same material is used. You don't get the strength of really the raw material. It's still quite ductile, so you still get like 50% of elongation at break, but the strength is a little bit lower. So you start yielding quite soon. It is way stronger than a normal 3D printed part. But plastic part, yeah, exactly.
Yes,
but
I would hope for that.
It is not as strong as a direct metal laser sintered part. It's somewhere in between, like a normal good plastic part and a DMLS part. It's a really interesting process. You need to have applications for it, because in the end, like 1 kilogram of finished part will cost you like $300, something like that. Yeah. With material debindering and sintering and the cost for the machine where you're printing it on, it is not cheap. But it might enable you to print structures you weren't able to manufacture conventionally before. Yeah. And the price for a machine that can handle the Ultrafuse material is way lower than if you would buy even the one-click metal machine, because you can print that material I even printed that on my CR10 with a hardened steel nozzle.
Yeah, I was going to say that the upfront cost for using something like Ultrafuse is way lower than getting into DMLS or any of the other processes that can give you a quote-unquote solid metal part. Because even the one-click metal machine that they've now officially announced is 55,000 euros plus, if you want that, a 24,000 euro cleaning station. It's basically a hot air, compressed air kind of debindering station and the powder sieve. I mean, I think material-wise, powder-wise, DMLS at that point is actually cheaper than going with the Ultrafuse.
Material-wise, yes. If you also take the depreciation of the machine into consideration, it maybe is not. True. But for example, for the one-click metal, it could be really competitive and even cheaper.
Yeah, and though again that is actual real metal melting.
Yeah.
And the appeal again of the Ultrafuse is that you don't need that upfront investment. And what Mac One Board is asking about is there a way of sintering at home?
No.
I mean, I guess you could figure out a way to do it, but it ain't gonna be cheap.
Yeah,
like it's not gonna be an approachable or affordable sintering and debindering setup.
As I said, you don't simply just burn out the polymer. It is like kind of washed out in this catalytic horrible.
Yeah.
Catalytic process.
Yeah.
It's getting late.
Keep going.
So you might find a way to do that, but I think it's not easy. There is a company somewhere in Canada or on the west coast of the US that has created a printer that kind of just puts down metal powder and sand in a kiln, and you end up with like a big container of metal powder and sand, and then you only take like this container and put it into an oven, and it's also you'll get a sintered part out of there. Joel, 3D printing nerd, made a video about them, I don't know, a year or two ago. That sounded really interesting because the investment for the machine was only just like $5,000. The resolution is not great, but I think it might be a feasible approach. I don't know if they're still producing those machines, but that's really interesting. I'll see if I can find a link and put it on the description.
Yeah. I guess to fully answer Andrew's question about whether 3D metal printing will ever evolve into the hobbyist market. What process do we have? We have the binder based stuff like Ultrafuse, which is I believe also similar stuff that the Markforged metal printer is doing, right? Yeah. Then we have the DMLS, direct metal laser sintering, or powder bed fusion, or whatever the other brand names are that they're being chucked around. Problems there, patent and lasers. You do need a fairly powerful laser system and all the safety stuff that goes along with it, and the shielding gas atmosphere, and the what's it called, powder spreader, basically wiper. The process itself really isn't that complicated, but it's just it needs to be perfect to work. Everything needs to be perfect, and of course the powder itself is also expensive
and dangerous.
So that's probably yes, it's quite fine powder that you don't want to breathe. So that's probably not something that you're gonna see in a low cost setup, because the parts are just always going to be expensive. What else is there?
What we talked about in the beginning, just like putting a MIG welder on a robot arm, or even on just a Cartesian 3D printer. This is something which is viable.
Which is called, Tony has done that.
Yeah, direct energy deposition, DED, that's called.
Yeah.
Basically, MIG welding on a robot, which is working. The problem with these parts is that they are really rough. And if you take a look at the machines of DMG Mori, who are doing DED with powder, but basically
Yeah.
the same thing. They machine all of the surfaces, but I think there was the bridge that was like
I've seen
welded
that.
with robots, which is somewhere in the Netherlands.
Yeah, when it doesn't need to look pretty or be super precise, like you can do that.
Yeah, that wouldn't be too expensive.
I guess there would be also a bit of an issue with warping and all that because you still, I mean, warping is a problem with DMLS as well.
Yeah.
Because obviously you do introduce a lot of heat in one spot and then have the part mostly cool down before it's the same as with FDM. It's just way more extreme.
Yeah.
So yeah, that maybe is the one that is the most approachable still.
Yeah.
Because you need a MIG weld. The MIG welders are fairly cheap.
Yeah. But again,
and the robot arm.
Yeah. And software.
Oh, it works on a 3-axis.
Yeah.
Yeah.
But I don't see metal becoming really popular thing in the next couple of years just because it's so expensive. If you're looking for strong parts, buy yourself a CNC router or CNC mill and chuck them out that way, I'd say.
And decent CNC routers are getting fairly cheap, especially if you want to do smaller parts. And stuff like DMLS doesn't do large parts either.
Yeah.
So, a small Chinese mill or something is probably a better idea than trying to build a laser powder bed fusion machine.
Yeah. All right. Last question. Maximilian KJ Arnold was asking, why are all the 3D printing YouTubers shilling or reviewing Chinese printer? And why aren't they doing that for Western or European or American 3D printers?
Do you want the simple answer for that? I get about 3 to 4 emails every day of a Chinese manufacturer going like, hey, Tom, do you want to review my printer? We're going to send you one. I don't get that from Western manufacturers. It's just, Chinese manufacturers are way more keen to get their printers reviewed by people like us. Many of them downright go like, hey, what do you charge for a review? And I'm like, I don't charge for reviews. Sorry. But business practices are just different in China, I guess, which I've learned that it may be taken, down the falschen Hals. Is there an equivalent?
Get it into the wrong neck.
Yeah, I mean,
misunderstand it.
Yeah, misunderstood, alienate us Western folks, but they're very keen on just getting the machines reviewed. And also, you guys are asking us for the reviews of the Chinese machines, so
because they're usually cheaper, those machines.
Yes.
Yeah.
Yeah. So that's what you guys want to have an opinion on and want to buy. So, I mean, I'd appreciate if a Lulzbot came along and was like, hey, you want to review the Mini 2? I've reviewed the Mini 1. Sure. But I'm just seeing that many Western manufacturers are also moving up in price, and Chinese manufacturers are starting to take that lower price bracket exclusively to themselves. Maybe, Prusa Mini, something like that. But yeah, the Chinese are just way better at pushing their printers.
Marketing budget is higher. Yeah, I think that's it. Yeah. I guess.
Yeah. Man, it's getting late. Why do we keep recording these extra? We've already taken out topics out of this one.
Yeah. But I think that's it for today. Or?
Yeah.
So
pretty much.
Thank you guys for listening. Thank you for being that patient and not expecting a podcast every 2 weeks. Sorry for that.
Thank you for still listening, even though we don't have chapter marks.
Yes.
And as always, if you want to support this podcast, you can do so through either Patreon on either of our two Patreon campaigns. Do we have we should probably do like a PayPal or direct account or something.
Yeah.
I don't know. Is that something that we should think about? Because, I mean, this podcast is work for us. It does take time. We've talked about this at Formnext. It takes either of us basically a working day, at least half to a full working day to get this thing edited and uploaded and all that. It does take time. But we appreciate that you guys are listening, watching, giving thumbs up, sharing the podcast, subscribing on YouTube, and doing all those awesome things. Yeah, Stefan, thank you for your time.
Thank you for yours. Thank you for your time, listeners. And I guess we see you in the next one.
Yeah. Goodbye.
Bye.
Time to record the intro.